the energy needed to break solid bonds and form a liquid, when we are at the melting point of that solid, the melting point temperature, that energy that we put in is called the latent heat of fusion. We need to put the energy in to break the solid bonds, and they form weaker liquid bonds. When we've got the liquid and we heat up the liquid to its boiling point in degrees Celsius, then any further energy we put in is used to break the liquid bonds and form a gas. That energy that we put in to break those liquid bonds is, wait for it, the latent heat of vaporization. It's actually got just an O, vaporization. Latent means hidden, so the energy is hidden in the bonds, and we form a gas. So for this situation, we were heating up. We were heating, adding thermal energy. And so we were breaking bonds. Breaking bonds. But what if we were cooling? What if we were cooling a gas down to its condensation point or its boiling point, where it's going to condense to form a liquid? And then we cool the liquid and it gets down to the melting point of the substance and it becomes a solid. What happens then? Well, when we do that, then cooling the gas down, the liquid bonds form. And when bonds form, that's when energy is given out. So the latent heat of vaporization is given out when we cool a gas down and we condense it. And so this way, we're going to be cooling, and we're going to be making bonds. Making bonds. Energy is going to come out. When we cool the liquid down and it starts to freeze, then we're making solid bonds. And energy will be released. That energy is called the latent, hidden heat of fusion. And that's the idea of these two phrases. All about making and breaking bonds. We've got a graph of temperature versus time for ice, heated from 0 degrees Celsius, that's its melting point. Use the graph to help you explain the latent heat of fusion and the latent heat of vaporization, using the idea of molecules or particles. So let's see what we can do to just clarify this. Okay, so here we've got the ice at 0 degrees. This is ice and water in a kind of transition phase, and we'd actually call that a phase transition. So at 1, we've got a transition, a phase transition from the solid ice, and we are breaking the bonds of the solid to form a liquid. So that means we're having to put energy in. So energy, so latent heat of fusion is needed to break the solid bonds. Okay, so once we've got to the end of that transition phase, it's all liquid, it's all water, and then we continue to heat with the heater, and that's when the temperature starts to rise. Notice that the temperature is not rising during the phase transition from solid to liquid, because any energy that we put in is used to break bonds, and not to make the particles move faster, because that's temperature. So we heat the water, or the liquid, and we reach its boiling point. Okay, so at the boiling point, we start another phase transition. Phase transition. And this time, we're going from a liquid to a gas. And we need the energy, the latent heat of vaporization. Vaporization is needed to break the liquid bonds. And notice there's no rise in temperature. All of the energy is used to break bonds rather than increasing the speed of molecules. And then we have a gas. So up here is fully gas, up here is a liquid, phase transitioning to a gas. Here we just have a liquid being heated, and here we have a solid phase transition to a liquid as we melt it. Now this process can happen in reverse, and if we go in reverse and we cool the gas, then we have the phase transition from a gas to a liquid. Now instead of having to put energy in, energy will come out as the liquid bonds form. And an example of this is if you are unlucky enough to scald yourself on the steam coming from a kettle. That's water vapor gas condensing on your hand to form water, a liquid, and it releases energy as those liquid bonds form, and that's what can really, really burn you and injure you, as well as the high temperature. Going further, and we're cooling the liquid at the melting point or the freezing point, we are forming solid bonds, and as you form bonds, then energy is released. So this way, we are breaking bonds, and we're having to put energy in. This way, we are making bonds, and energy comes out. Bonds, energy in. Hope that makes sense. See you in the next flashcard.